My name is Satyajit Sinha. I'm based in Hamburg, coming from IoT Analytics,
Okay.
and we are a market intelligence provider, and we provide market intelligence to IoT community. Today, we're going to talk about do's and don'ts in the electronic manufacturing, specifically for LoRaWAN devices. You can see I have a smartphone. I'm not checking my WhatsApp messages. It's more sustainable, I think. Before introducing our panel, I'm going to quickly want to address also that electronic manufacturing is one of the difficult job, right? And in the industry, we have seen that there's a lot of difficulties going to restarting manufacturing from bottoms up. And hence, it's my honor to introduce the panel today to talk about these one of the critical topics as well. So, Violent Su, she's a business development manager at Seed Studio. Violent explores builds and strengthens partnership across ecosystem and communities and academia to industries. She's actively involved in Seed's Tech to For Good initiatives. Kevin Brown, a principal product and industrial designer and co-manager of UK and Europe client partnership at RAKwireless. With over 23 years experience, and let me repeat, 23 years of experience in a very high volume consumer electronics sector, Gavin designs and engineers consumer-grade IoT products covering everything from user interface to mechanical design, hardware, and factory infrastructure. Xavier Dupont is a leading business development for SG Wireless worldwide with 20 years of experience in IoT and experiencing in deploying 3 million devices worldwide. Xavier simplifies IoT through end-to-end design and multi-radio modules. Welcome, everyone. Just to start with, just a very high level, just to open the conversation, this is my question to all my panelists, what are the best leading practices when you see in a development of manufacturing of these LoRaWAN devices? And could you share specific technical aspect which is crucial for this development? We can start with Gavin as well.
Thank you. Hopefully my voice is loud and clear. Best practices, technical aspects as well.
Yeah.
I think I come from this through the lens of design and from a very high volume consumer electronic background, using scale of many, many millions. I think it all starts with design. That is the start. It's not leaving anything to chance. The best practice really is design everything, address every possible detail you can, and don't rely on luck alone. That would be my short answer.
Yeah. That's great. Violet?
Hi, it's an honor to join this panel. I think from our own experience at Seed, the main most important practice is you need to take the actual real-world application into account. This might seem like a cliche, very obvious, but two example is like, for example, when it comes to LoRaWAN products, and then in is wireless communication, and then, for example, with a tracker, you need to put antenna for LoRa, for Wi-Fi, for Bluetooth, and then even like and GPS in it. So in a tiny body, you need so many of the communication. How you can ensure that it works on the one hand, theoretically it works this way, but on the other hand, in real world, whether it works or not. So you really need to take that into account when you choose different components in the design stage, and then test both in the lab and in the field as well. Similar to like outdoor device, you need to think about the temperature, humidity, and components and all the stuff. So I think the most important is that you need to take into account what you expect it to be used, and then think about it even in the design stage and then production as well.
Well said. Great. Xavier?
Yeah, thank you. So, electronics. Generally, when we say electronics is still the poor child of the family, unfortunately, it's still a little bit the case. There is a lot of, or let's say, IoT is a new space. So for lots of developers, it's they don't have necessarily the practice to make products which are used to, and I would definitely agree with you, that looking at the real-life application. I can give you an example. For example, when we deployed in Singapore thousands of devices, which were endpoints, connecting with LoRaWAN, and the utility over there had to guarantee 15 years on the hardware. And like you said, in consumer, you generally give a warranty of a few years, and that's it. And that's where you generally have this tension between the world of IoT, the world of hardware, electronics, and the practice of the market segments. This is creating lots of issues. So what we had to do, for example, in here, was to find a specific process. In a way, of course, we would glue the electronics into a resin, did conformal coating on the PCB, in a way to, so the partners, which had to commit with penalties in case the product was not going to work, could say, okay, I can stamp it and I'm going to support the hardware for 12 years. So adapting, the short answer is adapting the electronics to the practice of the market it's going to.
I completely agree. Like, but of my experience, what I see that ODMs has a huge responsibilities. Designing is one of the key aspects of it, and then definitely execution of it, making a proper processes is very important. But given you have experience in this a lot, and I want to understand from you, what are the common mistakes? Like, obviously there are two aspects of it. One is basically what are the challenges of it, but which has been faced by many of them. But what are the common mistakes that you see in this process of electronic manufacturing, and which you have seen from a lot now and are still happening, these mistakes that you've seen by that?
It's a very good question. And coming through the lens of design and my long career in design consulting and working with many customers with RAK, the big mistake in the whole journey, it's, I think, designing for one, making one on my desk, and assuming that will then scale. We can use the Xerox machine and make millions. Yeah. There's a difference between design for one and design for many. So this is one of the big mistakes, I think, is again, comes back to design, appropriate design.
Yeah, I think that makes sense, because IoT is not set for everything, right? You have a specific application required, specific sort of design. Do you want to add on it, on top of it?
No, I fully agree. We've seen this mistake so much. We had a anchor customer, okay, let's make it generic and sell, and we'll sell millions. And this doesn't work.
Yeah,
clearly.
Xavier, from your perspective, I want to understand, that obviously that these LoRaWAN devices has the capability, need to required for years and years in the field, right? And some of them may have a very less touch point of maintenance going forward. How we ensure in manufacturing, that the quality and testing, what are the methods we should apply in this stage, so we make sure that devices are reliable and top quality, and also will able to perform in the field in optimum way.
Okay, so when we talk about hardware, there is hardware and firmware.
Yeah.
And clearly, with the technology change, which has been also a big issue in the general communication field, where the technology change every 2 to 3 years, how, again, do you guarantee your 12 years for the metering space on the hardware with a radio which will be still supported, and on the firmware? So on the firmware, I've seen generally, if you know what you do on the electronics, pure hardware, you can avoid lots of issues. But on the firmware, having simple stuff which looks very basic to other industries such as IT or even mobile phone, firmware over the air, supporting being able to upgrade not only to the application but to the core networks. This is still security of the device as well. This is still not fully understood by lots of companies which deploy in IoT.
Interesting. I completely agree. I think also it comes on to the first top point you said, that there should be a certain set of processes and practices that everyone should follow on the quality testing as well, right? Important. But I think design is also one of the key aspects. And what I want to understand from you, like, generally when I, as a layman, think of a design, we say like is either it will be industrial, either it will be consumer, but are there any other more aspect of design for manufacturability? What do you see in your experience?
Yeah, for design, like you mentioned, it in the end, it might go to developers, it might go to consumer or business, but it needs to be live before it can be applied. So for the design process, when we really see the importance of design for manufacturing, or it's like a short for DFM, and then in this process, we need to consider a few things. One is about the functionality of the products, like when you design that, whether like in your laptop, and then it seems to be working with everything, but whether it's actually working when you produce it. And on the other hand, when it comes to product, it's not just one prototype or maybe 10 prototype. It might come up to a certain stage, 1,000 or even 10,000. Then you really need to think about whether it's compatible to be manufactured from the level of cost, from the level of materials, whether it's supplied for short term or for a long lifetime, and also whether this design, when you produce 10 pieces of it, maybe one failed, but if it comes to 10,000, there's like 10% failure already. So that kind of defect rate or the yield is very important to take into consideration as well. So that's why in this process, in the design, either your manufacturer or maybe your design partner really need to go through this with you as a designer and implement that before you actually put it into production for a manufacturer only, like pure manufacturer, and say, okay, this is what we produce to you, and it's exactly as what you provide to us. But in this process, there are many services in between which can help you avoid that, to help you lower the cost or increase the yield or shorten the lead time.
Yeah, makes sense.
I can add.
Yeah, that's
okay.
very great. Yeah,
Design for manufacture, very big topic.
Yeah.
It's very close to our hearts.
Yeah.
And to extend to previous question you gave to me, another mistake is that design for manufacture is somebody else's problem. It's the factory's problem. Or they sprinkle some design for manufacture dust later. It's too late. Or the developers treat the hardware like software. Oh, I can keep fixing it forever. I keep changing it, push an update. But when you deployed 1 million devices, you can't go and change them. So
True.
design for manufacture, design what it is, you cannot separate them. They should be done early to avoid pain.
Correct.
And I think NASA has some kind of saying, it's like test as you fly, fly as you test.
Yes.
True. So all those philosophies together really help you avoid the pitfalls and mistakes and achieve some success. Sorry to,
No, that's exactly right. And to complement what you just said, what we tried, for example, and so at SG, so which we are doing design and manufacturing.
Correct.
So we come a bit from the manufacturing world, and clearly what we say, you always have this battle in every company. R&D operation team, R&D pass everything to operation. Operation try to do the industrialization and process implementation. Doesn't work, go back to R&D. 1, 2, 3 times, your project is dead. Generally, 9 months is gone, and you miss your windows. So what we try to do in SG, for example, was not to reliability tests. We have the standard reliability tests in factory, drop test environment, etc. But for example, adding real communication, having simple stuff like having a LoRaWAN tester, being able to test with the customer application, having your factory which is connected to the customer database, which is what we did also. So then whenever there is one device which is tested, we have the traceability and the test report from the factory. It is happening in consumer. It is not happening yet in a lot of IoT application, which sounds crazy because it's a lot more demanding to have an IoT solution than a fridge or rice cooker.
True.
Like this.
True. Like I completely agree. Like obviously designing of them would have a futuristic aspect because these devices gonna deploy in, for example, in industrial. It's a harsh environment. You need to take into consideration of this and account that it need to be ruggedized. With design, I think one of the key important, Gavin, I think you will relate to it more on that, is the component supply. Because we see in the world right now, there's a chip shortage happened. Many of the companies started redesigning their products because of the components. And there are some US concerns on the suppliers on the global market, right? From a security point of view. So I think it's very important to choose the right components and right suppliers. How do you make those decisions, specifically looking into the LoRaWAN devices?
That's another good question, because many have suffered the pain
Yeah.
of recent times.
Yeah.
Yeah, and now they learn the lesson. Again, it's a similar philosophy to my previous answers. You can address these topics largely from a design perspective, but also a relationship point of view in the supply chain perspective. I can give an example of some mistakes that were made in other projects that I've seen where people design in components that are very unique.
Right.
Even the simplest thing as a screw. I've seen somebody designing a screw. There's a very special type, and it's made for that product. Is a bad idea from an electronic point of view. Components. I've seen in common use cases where people would design multiple footprints to accept different components if they need to change quickly. It's not always the case. It's possible, but I think just preparing, thinking ahead. What if this goes missing? How can I insulate myself, buy myself some insurance to adapt quickly if my supply chain suffers some issues, and engage with the supply chain even in the very beginning of your project to make sure that supply chain can support you and have more than one path in the supply chain.
Correct. Yeah. Xavier, you want to add anything on that?
Yeah. No, just it reminds me a lot of challenging time of my life. The pre-COVID or pre-component crisis.
Yeah.
I was stationed in Asia for 15 or 20 years. We were a little bit spoiled in the sense that we could have access to components pretty quickly because the supply chain was super efficient. Then suddenly everything stopped. TI has no supply for 55 weeks or whatever, and then you ended up, like you say, for a tiny component of 50 cents, you don't have dual footprints, and your whole product cannot be produced, or you have to buy to brokers. I mean, lots of us went through this challenging time. What we were doing as best practice, or what we are trying to do, is at least to have direct relationship with the top 15 supplier. Arrow and DG they are doing great job, but if they are your top suppliers, I think to me there is a problem. That's the way I see. You need to have direct relationship with the technology vendors. You need to have supply agreements, dual footprints on some component when you can. I think without over-engineering, I think it's possible. And already you reduce your risk quite a lot.
Yeah, makes sense.
I think also money talks. So if you have a large volume,
Yes.
then it's not a problem. So my previous role before RAK, I was developing consumer smart home products. They were made in tens of millions, and the chip shortage didn't affect that because the design was insulated from that problem. But because the volume was so high, you make friends automatically. So it's another strategy.
I know few of the company who didn't get affected because of their huge volumes.
Yeah.
Interesting. Just wanted to circle back to you, Xavier, on that regulatory compliance and certification. And this is a very key important part of the devices part, right?
Yes.
And this is still a very huge roadblock, I would say. It's not a streamlined process. How can manufacturer, streamline it, manage it in a way that it has become not takes years and years to get the certification, but basically a smooth process to do it.
Yeah, and it's back to what you were mentioning. Once the hardware is done, yes, you have to pay 20, 30, 50, 100K certification costs.
Yeah.
You don't want to have to change anything which alter your certification. So the labs, having a close relationship with the lab, we are doing pre-tests on every of our product. We used to have also our own testing equipment. But that's also something that the hardware engineers, and sometimes you have tension between the cloud guys, the firmware guys, the hardware guys, which are like, okay, can change this and that. It's like, no, if we do that, there is more emission, we have to redo the tests. And this kind of discussion can go back and forth. Again, understanding that hardware is not that simple, and like once you freeze everything, it's frozen, and doing as much pre-test as possible before, trying to might reduce the risk after.
Okay. I will come back to you, Gavin, but I want to understand from you from a demand side of it. Do you see users even have awareness of this certification, or even when they ask when they looking for that? Do they? What does the experience says about from a demand side of it?
Demand side of that, like certification?
Yeah, from the users, do they understand that there is a certification requirement for these devices? Do they care about it? Like, I want to understand from a demand side of it, what is that their perspective on that?
So, like from the demand side, for the certification, like when it comes to LoRaWAN, like the most common is like the wireless certification required for it. But on the other hand, when our partners or like in the community, when people come to us, we will actually need to talk with them about where is the expected application that you want to use. On the one hand, of course, the market, the region that requires the certification. But on the other hand, maybe when it's applied in the food or even in some industry, they need other kind of certification that is very specific. And the customer themselves, they might know that part of the industry certification, but not the other part of it. So in this process, the conversation is really important. And then when it comes to the certification side, it will be really crucial if the designer, like they come and say, I have a customer who need this product in this application, but I need to design the product. Then if they choose the modules that's already certified, then it will simplify the process and shorten the lead time very crucial, significantly. But if they start from something that's totally new, and then there's like, I need to certify this, it takes about how many months, and then maybe with the pre-testing, it doesn't pass it, and then need to tweak it and restart. So I think when it comes to that, will be two parts of certification, the wireless, like technical wireless part, but also the application for the specific zone, like ATEX or maybe food or medical and all those industry vertical kind of certification, and choose the components, or not exactly chips, but modules that are already certified or proved to be certified already in some of the existing devices.
Interesting. Gavin, any you want to highlight anything important?
From a demand side.
And even not a demand side, like for you, I think
Certification.
multi-product, I want to understand from you, because multiple product portfolio required multiple certification, which added more issues. From that perspective, if you want to highlight anything.
I think maybe I could add one pitfall in the certification domain.
Yeah, that will be
blends everybody's
Yeah,
perspective together. It's where I've seen projects where certification requirements come in very late.
Correct.
There's a new opportunity for a product that hasn't been considered already, and you're a long way down the journey.
True.
And then somebody says, okay, now I need ATEX certification. It's like, wow, that's a different story. We would have done a different product to this one. So it's being aware of the future, predicting what you need, preparing to be in the right place at the right time to smooth the certification process, but still arrive at a product that's fit for purpose and going to satisfy its needs. Because, late changes get more and more costly.
Yeah.
Great. On the last one question, I want to go with all of you, and I want to focus on the security aspect of it. This is very important because design from security perspective is also important in the current world right now. How much it is important, how much is the challenge, and how much it is an effort from your end to see that from a design perspective, implementing security at the hardware level, implementing at the maybe some of the application required secure element. What do you have experience from your end? Xavier, you can start with.
Okay, yeah, so security, very big topic. I mean, for 20 years I've been in this space, I've been gospeling this, and unfortunately, lots of our customers were not really mature to do anything. And it's quite scary for our field, because you have millions of devices which have absolutely no security. Or the only security is that the firmware is supporting a language that nobody knows. True. Because it's done internally, it's closed, it's not open source, and that's it. And if the developer goes, they even don't know how to update their own firmware. I've seen this happening many times. Simple stuff, secure element. We are doing medical. Managing a secure element product is a pain. You have to do everything from at the factory level, and sometimes I've seen some medical companies cutting corners on security just because they wouldn't want to pay for the extra on implementing secure chip. Using open platform, using custom language and protocols are two also big topics which companies need to be clear in terms of strategy whether they will trust a community to support an open platform such as embedded Linux or any kind of FreeRTOS, or if they want to do their own stuff, and how they will implement security and scale. And generally, my answer is open platform is the only way to survive.
Yeah. Gavin?
From a security point of view, I think many define it as software, digital, virtual, but actually it's also in the physical domain.
Okay.
And I've implemented security strategies and philosophies in the full end-to-end, from even factory infrastructure, physically prohibiting access to something, and even in the end device, some electromechanical kind of elements of security. So it's a full holistic approach to security. A lot of people very noisy with the software world, but there's still the physical thing. So that's very important to consider, even from end to end.
Right. Your perspective on that?
Yeah, I think when it comes to the security side, on the one hand, it's like we need to really, when we design, there are some the industry standards we really need to adhere to. But on the other hand, when people come to us and say, hey, your device is totally like in this level, we couldn't touch anything, but we really want to do it in our own way. In this case, we will say, okay, the reason why we do it that way is we really need to have the algorithm to protect the secret level of the data or information in it. But if for specific customer who really want to do it in their own way, then we can consider about we couldn't change the standard level of the products because it might affect other users. But on the other hand, we can customize a specific firmware for this customer, for their application. So it is in their hands for them to manage on their level of the application.
And nicely put. Great. Thank you. Thank you for the interesting discussion, and feel free to reach out to us if you have any questions. I hope this discussion helped us to understand the do's and don'ts of electronic manufacturing, specifically in the LoRaWAN devices. Thank you, everyone.
Thank you.